So we have this input subroutine. So today we are going to create one more subroutine. I will call it output. Just delete this one. So let's create output subroutine, and for this subroutine we will need output variable table. So I'm going to call it outputs because the name should be different. And let's create a variable. Oh, sorry. Like this. And for this, for physical output, I'm going to use the tag, this one, Q. And let's take on first output we have green light, for example. Export it. Let's give it a name, outputs. Let's drag. So the second output will be, for example, red light. This will be for spear. I will give it a name too, according to the output name. And let's take, we have other registers. Let's start with output number 20. And for this example, we had two motor ready signals, so I'm going to control these motors. So this will be, for example, 1 and 1 forward. Let's make like this. Another will be reverse. This will be, for example, it's variable frequency drive. So this will be a reset signal. Copy, paste, and the same for the other motor. Also, I would like to add some more. So in this example, let's imagine we have a vacuum suction pad. So just add vacuum valve, and this won't be for spare 27. So we have some physical outputs. What I'm going to do, I'm going to copy all of them. I leave gap here just for better visualization. What I would like to do now, I'm going to create other variables. So here, this symbol I'm going to replace with this symbol. And we must decide where to start addressing. So let's take it M200. And we have this one. Now let's do the same. Replace with this, with this. This, I will show you later. Okay. Let's start the addressing, for example, from this point. Oh, maybe we can use another 100. And one more. This will be for HMI. And here, let's start, for example, in the same 100. Let's start here. We don't have many variables, many outputs, only about 10, so 12 for it. So now let's delete the empty lines. Save it and go to add our output symbol table and import. Clear the table. Output is selected. Be sure it's not other file. Okay. There is one more thing I would like to do. I'm going to create another subroutine. Let's call it, for example, control, or we can add control panel. Just leave it control. And for this one, I'm going to use another global variable table. So this one I'm going to call system variables. And there is one more important thing. The output subroutine must be at the end, not somewhere in the middle. So I will move this one to the middle point, control, but this is only for visualization, because what we need to do here is go to the tasks and be sure the output is on the bottom. Okay, so we have system variables. I will add some variables here. Let's start addressing with 100. For the inputs, we have started by 0 m. For the outputs, we have started by 200. So for system, let's use 100. And here, what I would like to add for this example, it's one of my favorite bits, is system ready bit. I will add here manually more. It will be so another bit, let's call it process, or we can, okay, let's make it a little bit different. Let's call it mode automatic. And one more, we need mode manual, and the address will be this. Looks well. So let's go to the output subroutine, and now here is the point. What we have here in the outputs, we have some lights, we have motor control, and we have pneumatic valve, vacuum valve. So what I would like to do, I don't want to put everything in one subroutine. Let's make more subroutines. Why? Just because when you have not many signals, it's okay to put everything in one, but once you will have 50 outputs or 100 outputs, it will be very complicated to find everything. So I would like to group now. So let's say this will be output LED. Let's make another, for example, output motors. We can also add one more, for example, output motor reset, for example, because we have reset signal to our VFD, or we can call it here VFD reset, but it's about the motors, so I will leave motors. Okay, I don't like this S, output motor. And we also have pneumatic valve, so let's make it output valve. And the first thing, I would like to go to motor side, to motor subroutine. Let's see our cycle task, input, control, LED, motor, motor, valve. That's okay. So let's go to motor and let's make something what looks like this. This thing. And here, what I'm going to add here, I will add here system ready bit. I'm gonna add here Q. Here will be H. And for example, here will be mode automatic, and here will be mode manual. So for mode automatic, we are going to use this bit with A tag, and it's not a full name now. And for manual mode, we are going to use this one. Okay, so now I'm going to copy, paste, 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 and okay, enough. So the first will be 1M1 forward. I will copy this, only this side, and put it here. Paste, paste. Another will be reverse. Copy this part. How easy it's to make it. Another motor will be 2M1 forward, HMI, and this will be reverse. Okay, so we have this subroutine for the motor control. Let's go to motor reset. I will paste this. Okay, so for motor reset, let's imagine we have some of the bits we can ignore, don't use. For example, I will explain you. Okay, let's go here and I'm going to explain what everything means. So this bit we are going to control in this will be mode automatic. Okay, this will be for automatic mode. This will be for manual mode. System ready. What this bit we are going to control is our control subroutine. Here, this point is our physical output, and here we have, like I say, just indication of the output. For many years I was using this bit, but technically it is not very necessary to create it. But I am going to use this bit in my HMI program. So in HMI, as the output visualization, I am going to select this bit, not the output address. Why? Because what if we will need to replace the output? Maybe it's faulty, or maybe we need to put the signal on another output. So when we will change the address here, we will need to go to our HMI program and to fix HMI bit address. But once we will use this bit in our HMI as an output visualization, it will be not necessary to go to fix our HMI program. In many years I didn't have many situations, only maybe just few situations when I needed to do these changes, but I decided to use this structure, so let's keep this bit together. If you don't like it, you can delete this one, make like widgets, but I'm going to use in my HMI this bit as the output visualization. And also in the program, so for example, my output failed, and I'm going to replace with, for example, this one address, yes. So I don't need to go to HMI to fix this address. Okay, so we have motor controls. Let's go to motor reset, and here we have Q1M1 reset, and here Q2M1 reset. Let's make a visualization, but I'm not going to use visualization in reset signal visualization in my HMI program, so technically we could delete this, but just leave it for the same structure. So reset signal to our VFD, when should be sent? As you remember, we have in our input we have drive ready signal, so when the motor is not in ready, this one is not ready, we can set reset signal. And now where is the point? We can use direct reset signal or with off delay. I will leave it now this one, but technically you can use and with off delay function. Let's make it with off delay, doesn't matter. So remember we have, okay, let's copy this. So remember we have vacuum, so let's make it for the vacuum. And for the vacuum I'm going to use only this one, because it's a different situation with pneumatic valves. For example, for the motors we have here all the protections. We can also add here, for example, if we have some input, I will not but describe it. We are going forward, for example, we can add here positive limit switch. Do not make it. No, so this motor will be running only when we have system ready bit and positive limit switch is not reached, so we can run this motor only in this way, but I will delete this one. But for example, for the vacuum, let's imagine we grip something and lift, and we don't want to use this to lose this signal by pressing emergency stop button or something, because it's the vacuum suction pads, so we will lose the product. So what I'm going to do, I am going to use only this one bit in this subroutine, and let's go to our LED. Let's make like this, copy, paste, and here we have green, and here we have red. H LED green, H LED red. So then should be green LED on. Let's imagine we have green LED to display. We are in automatic mode. Oh, sorry. Mode automatic. And red LED, let's imagine we don't have system ready bit. But what I like to do is to have two states for the red LED, I always said. So one state when I don't have system ready bit, what I do, I am blinking it. So let's add blinking. Do not use high frequency, especially if you have relay output here, not a transistor output. So be careful with this. Do not use high frequency blinking on relay outputs. And another, so when system is not ready, I will blink. And what if I will not have safety signal? That means emergency stop button is pressed. I want to light up. It will not blink, but will be always on. So let's go to our control subroutine. And here, what I'm going to add, just a simple example. We have safety, we have motor ready, we have 2M1 ready, and I'm going to enable this system ready bit. Okay, once the system ready bit is enabled, we can, for example, control our process. So what I'm going to do, I will start automatic mode when system ready bit is on, and when the start button is pressed. So I press start button, system ready is on, I set automatic mode. By the way, we can add here a trigger. Just what if our start button will stuck in, so it will not start automatically on the next time. So we can use a trigger here. And when to reset automatic mode, so one of the conditions is when not system ready, right? And another condition, for example, we press stop button. Let's delete this one, copy, paste. What we are going to do, we are going to reset it. And one more thing, so remember we have manual mode and automatic mode. So let's imagine our we can add here system ready, for example, bit, but it's not very necessary because we have here system ready bit, but I like to add it. So for example, when we can activate mode manual, when, for example, it's not an automatic mode. Let's try to compile. And I have already started my simulator drive. So download it to PLC, to simulator, and let's see how it works. Okay, so at first let's go to our LED. This one is not blinking, this one is blinking. I think it's only visualization issue. Yeah. And this one is not pulsing. Okay. Let's try to simulate this signal. Set it on, system ready. Go to our output, Oh, now it's blinking. As you can see, we have safety input is enabled and it is blinking because in our control we don't have motor ready bits. So let's go to our input and let's set these bits on. Go to our LED and check how it works. Now system ready is on. But why this one is trying to blink? I don't understand. It's only monitoring issue. I think the address was this, right? Yeah. Let's try to monitor it. Yeah, it's only monitoring issue. So let's ignore it. So let's go to our motors and why monitoring is so crazy. System ready is on. System ready is not on. I had this monitoring issue. Let's try to restart the computer, maybe it will help. Okay, I think I have solved this issue. The point is, we need to go to our control and we need to change our region to English United States because I am from Lithuania. By default it was Lithuania, so I have changed the format here and now it looks like it's okay. Let's see. Yeah, here is OK. Now system ready is OK. Okay, now I know this issue from the earlier. So now it's okay. What I want to do is to activate the signal because it's normally closed. Let's remake it a little bit so we will have better visualization for this. So I'm going to make it like this. It's the same. I have only made inversion here. So it's off, it's on, so well, this is much more better for visualization. So let's go to our control. As you can see, now manual mode is active because we are not in automatic mode. You can add more conditions here. Maybe you have a switch or something for manual or automatic mode. This time I have decided to separate it with, if not in automatic mode, then we are in manual mode. So go here and you can see we can run the motor, but once we will go to automatic mode, let's start it by pressing start button. I have added delay here. Okay, let's leave it now, but later I will delete it. Now you can see mode automatic is on, and if we will go to our output motor subroutine, the motor is not running, even this bit is on, because it is for manual mode. So I'm going to create now HMI window and I will show you. Let's make a new project, select any of this, new HMI, blah blah blah, and I'm going to use Ethernet communication. So this is my controller address and I'm going to use it for simulator, for communication simulation. Let's select this let's leave them empty, and here just try to add, okay, one button will be for safety, so safety when it's off, I am going to display it in red. It's like emergency stop, and when it's on it will be green. And the address was x0, check it again, input, yes, x0 is safety, so let's make this, let's make a size, for example, and it's not important now. Okay, safety, copy, paste. Another button is reset, start, stop. Okay, so now it will be x1, reset, style. Let's make it white when it's not pressed, and when it's pressed, let's make it blue according to button color. Another will be x2, right? Start, what I would like to do, I would like to reduce this timer. Start, when it's not pressed will be white, when it's pressed will be green, okay. And another button was stop. So when it's not pressed, okay, I will make it normally open now for this time. So let's make it when it's not pressed, but when it's pressed, let's make it red. Okay, align them and make the same space. Save it in it. Okay, what we are going to do, I have made this normally open, so let's delete this one. Set off. And let's start our line simulation. So now we have the control. Go to our control. As you can see, safety is lock, reset. Okay, I have made it maintain it. Let's make it momentary. Maintain it. Maybe I can do everything at the same. Maintain it, momentary. Let's try one more time. So go to our reset. Now I press, but the motor ready signal already exists, so I will switch it off. Let's go here and press reset. We are sending reset signal with off delay, as you can remember. We have 2 seconds of delay, although we have here, sorry, start button. System is not ready. This is why the button the motor doesn't go to automatic mode. So let's imagine we have resetted our drive, and now we are going to press start, and automatic mode starts. Stop, automatic mode stops. Start. If we will lose safety signal, it stops. One more time. Start, 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 stop. So this is the basic of output subroutine. So later in our program, when we can make here extra subroutines, one for manual mode, another for automatic mode, we are going to use these bits. So I just want to show you just an example. Let's add another button. Let's take maintain it, only one, and let's give it color blue when it's not pressed, and let's make it green when it's on. And here what we are going to control, this is manual mode bit. So let's take, we are going to control this one, motor forward. So writing value will be this one, M354, and read value, we are reading output state, not the bit state, because we have different bits for manual and automatic modes. So what we are going to read, we are going to read the output. You can use this output address. I'm going to use this address. So it will be 204, I guess. And let's try to simulate. Now as you can see, we are controlling this bit and we are reading this output. If I will start the process, as you can see, this bit is on, but here the motor is not running. This is why this one is in blue color. And here we have some dangerous situation. So because this bit has been left on, so what I'm going to do now, we can create, for example, another subroutine, manual mode. Let's move it up between control and outputs. So in this subroutine, what we are going to do, if not manual mode, right? Mode manual, we are going to reset. Just copy like HMI. Let's make it like this. And here we are going to reset 1M1 forward, reverse, 2M1 forward, and 2M1 reverse. Although, for example, we want to have reset function when we press stop button. So let's try now. Go online, go to our inputs, what we need to activate. Motor ready is activated, safety is activated, So motor. Okay, let's test it. We are running. We start the process. I have added it's still 1 millisecond, so I need to, let's delete this one, will be faster. Our application. One more time. Stop. Start. And let's see from here. Stop. We are in manual mode. We can control this. If I will press stop button, it will go off. Activate it again. Let's see this one. I press stop button. I reset on this one. Reverse. Yeah, small mistake, but it's, and for example we lose safety signal, it resets too, because it's not in manual mode too, because manual mode must be not automatic and system ready zone. And later in our PLC we can create, for example, process subroutine. Let's move it between manual and outputs, for example. And okay, what I'm going to add here, because I don't see the status of my, of my mode, so I'm going to add here a bit, which will be fixed, and another, let's make it green. Make it like this. So for our LED, green was M200. And another was M201. Here was red, and for the this state it was red. Okay, copy, go offline and check how it looks like. So, not safety, red is on, safety is off. Let's start process. Green is on, stop the process. Green is off. Not safety. Now we have full indication. So now I can manually control the motor only when it's in green, LED is off, and red LED is off. You can see how simple it is to have output subroutine. And now, for example, my situation is going wrong and I need to replace this address. For example, let's make it this one. But if I will run in HMI, I don't need to change this address because I have already used this one. So it's easy to do this. Another point, when we have forward and reverse, I will show you. Let's take, we cannot run forward and reverse at the same time, so we can add here, for example, not forward and not reverse. Here is the same, copy, paste, not. So now I will start, for example, reverse mode. It is running reverse, but I am going to enable forward, and forward is not activated because we are already running in reverse. Once I will stop the reverse, it will go forward. But here, for example, we can make another options. I will make it only with one motor. So when we are starting forward, we reset reverse. When we are starting reverse, we reset forward. So let's see how it works now. Let's try to run forward. Running forward. Let's push reverse. And as you can see, the forward has been resetted. We immediately go to reverse. One more time. Forward, reverse, forward, reverse. For this one, for motor 2, I didn't add this. So, as you can see, this is completely different situation. You need to reset it manually. So, while you write a program, pay attention to these bits, how to control them. Maybe, just maybe. There is another thing. I want to add some limits. For example, I cannot run the motor immediately after running forward. I can jump to reverse immediately. Maybe we have contactors here, so the motor decelerates a little bit. We need a small pause, for example. So let's check our timers. Let's begin with T10, for example. What I'm going to do, just add two networks and sorry, where is my mouse? Okay, so this one forward, this one reverse, and let's add TMR T10. And let's take, for example, 2 seconds for better visualization. So when it's not running forward, we'll add it here, T10, T11. Let's see how it looks like. Okay, so now I'm going to press forward. As you can see, it is not running immediately. It runs only some time. And let's press reverse. It's not running immediately. runs after some time. But in our visualization we are reading this value. So if the value here is much more bigger, for example 10 seconds, we actually could not know it's running or it's in running state, because we are writing to this register but reading this register. So for this situation I recommend you to add this timer. Why paste sometimes don't work with my V? Okay. Oh, let's make it like this. Okay. What I would like to do, I would like to add one more button. It will be reverse button, and I think the address is the next. I will only make it reverse, and this one be forward. Let's go to simulation and check. See how it looks like? We run reverse, but the reverse is not activated for some time. We run forward, we have indication we are going forward. Nice. And also, if we are in automatic mode, we'll press forward, it's running forward, we will press reverse, it's still running forward, because we only made for HMI bits with reset instructions, but it's very good visualization now. You can see we are still running forward, running reverse. Now I'm going to reset reverse, set it off, and forward is enabled, but with small delay on the output. This is just example how you can use this H bits. In this situation, let's imagine we are replacing this output with this one, and if this bit will not be used, we will need to rewrite it here and here. This one depends to this and this one. So this is why I like this bit to use. It's like highlight, output highlight with letter H. That's what I use. And for pneumatic valve, so remember, oh shit, let's set it back, cool, 1 and 1, forward. And for this one bit, so remember, it's dangerous station. Once we will set it, it doesn't matter. Will we press start button or stop button, or we will use safety, it's still on. But if you are going to control this bit in manual mode, let's make one more. Let's make it vacuum. For example, this was write address, this one, and read address, this one. We need to add a permission with interlock address. For example, this manual mode bit, which is 102, must be interlock address, interlock state must be on. Let's try. Okay, now we can control it, but if the safety is not on, if we are in the process, we can control. We activate it, we start the process, we can switch it off manually. Because I have added permissions, then I can control this bit. So, for today I think it's all. Maybe it's helpful for you. That's about the output subroutine and about the control subroutine. Manual control bits, and for automatic mode we must write a program, and it will be in the next lesson.